Okay, hello and welcome to the Convex development stream. And today we're going to be doing a little bit of game development and we're going to be adding some biomes to our voxel-based game inspired by Minecraft. So I'll just start off with a quick overview of where we are right now. So I've got my Eclipse environment here. I'm just going to run our little block game and it's going to fire up, just takes a couple of seconds. And in one moment, we have our world generated. And this is a classic block-based game, very much inspired by Minecraft, Dwarf Fortress, and roguelike games. We can fly around the world, we can explore, we can have a look at the caves that we made in our last session. And of course, we can edit the world. So we've got some blocks here, we can place them down and start to build our own dream home here on this nice little rocky shore. Okay, there we are, got some wood, and we've got some mushrooms, and various other items that we can place around the game. Now, one of the recent changes is that we now have an infinite world. So if I fly around the world, you'll see that it's generating new chunks as we explore, which is great. So we effectively have as big a world as people want to explore and build and discover new lands and discover resources. We just have one little problem, and that is we've only got this one biome in the game. So everywhere that land generates, we just get this nice grassy fields. We have a few scattered bushes. We have some little cliffs and caves and some trees. So there's a bit of variation in the scenery. But what we'd really want is a world that, feels different as we explore different parts of the world. So to do that, we want to create some biomes to give each part of the world its own distinct look and feel and perhaps different things to discover. Okay, so let's get into the code and start thinking about how we're going to do that. So I'm just going to quit out of the game and let's go into our world generation code just to see where we're at. So in the engine class here, and all this code, by the way, is available on GitHub, Mycera block game. We have the world generation class, and the thing that's getting called every time we explore a new part of this world is this important function here, generate area. And what that's going to do is take some input of the bx and by is the x and y position of the block which is being generated, and for each tile within that block, so sort of 16 by 16 area, we're just going to loop over that, and we're going to generate a tile for each of those spots. And there's a bit of calculation that goes on about what the height is of the terrain, and there's a bit of magic here to upload the chunk to the blockchain once it gets generated. But the key function here is generate tile, which is going to get called for each block on the surface of the land, and that also generates all of the rock underneath the surface. So it's sort of generating from a negative z right up to the sky. So if we go and have a look at this generate tile function, see what it's doing. Well, it's doing a few things at the moment. The first thing is it's doing calc height, which is the height of the terrain. It's filling with rock up to that height. And if the height is greater than 0, i.e. it's above the sea, then it's doing a little bit of logic to say, okay, well, what should the top block be? And currently, it's basically just using this grass block. So one of the ways that we can indicate different biomes is to say, okay, in a different biome, we're going to have a different type of block on top of the world at that point. And then there's a bit of other stuff like perhaps affecting adding some grass, etc., etc. But the essence is, okay, well, what is the top of this block, and what things are we going to add on top of this block when it gets generated? So in order to generate different biomes, we're going to need some kind of logic which determines what the biome is going to be. And I've just done a little bit of preparation and made a couple of classes here. We have this class A biome, which is going to be an abstract base class for the different biomes. So let's just start by creating a biome that represents what we currently have. So I'm just going to create a new class, and let's call this Grasslands. And we want the superclass to be a biome. Just create that. So we have now a Grasslands class that extends a biome. And let's go back to our world gen. Well, let's have a variable here to contain some different biomes. So let's make this private. I tend to make things private if there's no reason to access them from elsewhere. So we have a private A biome, and let's make it an array of A biomes. And let's have and we'll have a new Grasslands. Now we're probably going to want to use the engine so we can refer to it. So the constructor probably is going to need an engine. But let's see if this works. Let's create a constructor quickly. Import the Grassland. Now there's no constructor at the moment, so let's just create a constructor. We're going to want a super constructor, so we do super engine. That's world gen, isn't it? World gen. So just a little bit of plumbing, but this dot world gen equals world gen. So we're going to want a field, create field, and this is going to be protected so that all of the different classes can use it, but we don't really want it exposed to the outside world. So that should create a new Grasslands class. And why is it complaining? Probably because I haven't put a colon on the end. Private. Oh, it needs a name, doesn't it? I'm being stupid. So let's call this Biomes equals new A biome. So it's a bit tricky remembering the syntax for some of the things. And I'm going to import a biome, and I'm going to have a new Grasslands this. And let's say, well, okay, what's the current biome going to be? So private a biome equals, let's make it just biome 0. And we're going to say, okay, the top is going to be whatever the top tile is. So we're going to look at the current biome dot top tile, and I mean let's give it an XY, because I suspect we might want the top tile to vary based on the position in the XY position in the world. So we're going to create the method top tile. By the way, I often code this way. I often write what I want to see and then just let the editor fill in the code as we need. So we'll do tiles. What's it called? Lib.grass. Lib. That's exactly. Lib is our library of blocks. So lib.grass is going to be a top tile for our Grasslands biome, but of course this is coming to the A biome class. So let's just put that in the Grasslands. So, and we want this to override, since we're going to have an abstract top tile up at the top level. And in the A biome class, so this is going to be abstract. So it's going to be an abstract. It's creating a cell. A cell is just the type that is used for the block. So we don't need a method body if it's going to be an abstract class. So this should work. So we've got a world gen, and it's taking the top tile from the biome, which is currently just the Grasslands biome. But let's just see if this works. If this works properly, we should still just have a world full of grassland. So I like to test every few minutes as I'm coding, just to see that I've not broken anything, and it's looking reasonable. So I think that's a success. We've got a basic biome function that returns the top tile, and this top tile is then sort of populating all of the area around this. Okay, great. So we're going to have to make it a bit more interesting. We have to have a way to choose biome. So let's do biome equals select biome x, y. So we're just going to set this biome field at the start when we're generating a tile. So it's going to be a new method, select biome. And it's going to take an x and a y, and we can currently, I guess, return biomes 0, because we've only got one biome. But as we go on, we're going to want to change this so that it can support multiple biomes. And let's just test this out. Let's add in a new biome. So we've got our grasslands. Let's copy that. Let's paste, and let's have a desert. And I chose desert because I know I've already got a desert block defined for sand, so this should make it nice and easy. So currently a desert is exactly the same as a grasslands, except it's going to have sand instead of grass as its top block as a desert generates. So let's just save that. Go back into our world generator. So as we select biome, we might want to be able to alternate between the two different biomes. So long selected, let's go select int. We want an int because we're going to be indexing into array. Long select equals. Now we have a couple of functions that sort of return random numbers. So rand dot, and it's called rint, which is a random integer, and it just needs 3 parameters. So we have a maximum integer value, a seed for the x value, and a seed for y value. So it's going to return different random values for each seed value that it's given. So we'll have rand.rint. Now we're going to have 2 biomes because we've got grasslands and desert. But let's just do this as biomes.length. So we're just selecting randomly from one of the biomes, and we're going to go biomes from whichever one is selected, and get rid of this unnecessary code. And then our biomes, let's have a desert. And we can maybe tidy up this code to create this biomes array a bit later. But we're just trying to get the basic functionality working right now. So let's run this, see what we get. Okay, wow, that's a little bit crazy. So what have we got here? We've definitely got 2 different sets of surface tile now generating. We have obviously the green is the grasslands, and the yellow is the desert, but it's generating in a really weird pattern. So clearly something's going a little bit wrong with our seeds, and it's not really randomizing it in a way that's going to be appropriate. So this is not so good, but it's a good start. It shows that we actually have our 2 biome classes working, at least in the sense that we can get 2 different biomes and that we can populate these cells based on that. I'm actually interested in wondering if there might be some concurrency issues happening here. So we might have to come back and have a look at that. Okay, so let's quit out. This rand.rint doesn't seem to be producing things really randomly. So let's you try using a noise function. So we've got the noise functions. So let's say we want to use the plasma. We want to use x comma y. Let's give it some scale, a reasonable scale like 20, and let's do check if x and y are, yeah, x and y are global, x and y, just checking they're not block local. So plasma has an x and a y. I think it needs a z parameter, but we're not really using the z for this. Okay, so I think this is working, but our select obviously needs to be an integer. So let's just use the result of that. So if that value is greater than 0, then we're going to have desert, which is 1, and if it's a desert if it's 1, grasslands if it's greater than 0, and desert if it's less than 0. I'll just put in a couple of brackets just to make this less confusing. We're going to fix this later, but we just want to see if it's sort of at least reasonably working. So plasma, select the grasslands, select the desert, choose from the biomes. It's either going to be 0 or 1, so we shouldn't get any errors from being sort of out of space there. Let's just give this a go. So if we're lucky, the noise function is going to select the biome for us at each location, and that is looking kind of okay actually. I think that's reasonable. So we've got desert and grasslands sort of interleaved. We have this sort of classic plasma noise function, which gives this sort of quite natural looking variation between shapes between the two different kinds of areas. And we have and it seems to like go reasonably across the landscape. I don't see any obvious visual flaws here. And the frequency, so the scale of these biomes is like in the sort of 20 blocks region. That's about how long you expect, how the distance you expect between major changes. I see a couple of like square edges, so I'm a little bit wondering if there might be some concurrency issues happening there. If two blocks are getting generated at the same time, are the biomes clashing with each other? Because we made that a field for the world generator class, so it's going to be shared if there's multiple threads doing things at the same time. So we might need to have a look at that later and maybe put in some synchronization. But overall, I think this is looking okay. We've actually got two different biomes kind of working. Okay, let's roll with this and see if we can generate a couple more biomes and see how we can make this work. So I'm not really very happy with this selection function, because this is only going to let us choose between two different biomes, and potentially we want to have quite a few different biomes in this area. So the idea that sort of springs to mind is sort of having a variable which says, okay, well, which biome is most preferred in a particular area. So we're going to have a chance to generate many different biomes, and they're all going to get something like a score. And whichever biome has the highest score in a particular area is the one that's going to actually get generated. So let's have a quick go at implementing that. So in order to do this, we're going to have to give each biome a score. So let's loop over the biomes for int I equals 0, I is less than biomes dot length I++. And I'm not too worried about doing some loops in here. I mean, it's going to get one on every tile, but it doesn't get run too often, the world generation, and this will be fairly quick if it's looping over maybe 10, 20 biomes. So not a big worry. So let's do a biome B equals biomes I. So we're going to get our biome, and let's do B dot calc score. We're going to calculate a score. We're going to give it the x and y as parameters, and let's have a double max score equals double dot negative infinity. And as we loop over these biomes, we're going to do double score equals out score. And if the score is greater than the max score, then we're going to say, okay, biome equals B. So we're going to use that biome. And we're going to set max score equals score. So this will loop over the biomes. We'll give them each a score, and it's going to track the maximum. So whenever a new biome comes along that has a higher score, it's going to use that, and it's going to keep going until we find whichever one has the highest score at the end. So we are then just going to, well, we've selected it. We've done biome. So we're actually just going to return biome, I think, at the end. Yeah. Okay. Now we don't have a calc score in our biome class yet, so let's just put that in. And we're going to have a way to score these things, and it's obviously complaining because we don't have any implementations of this yet. So calc score int xy. So let's score using a plasma function. So double score equals, let's use the plasma. So we've got our world gen class. Plasma xy, let's just put in some test numbers for the moment. Xy, scale, and a seed. So let's do world gen.seed. I guess we can pick random numbers here for the moment. And we're going to return score. And that's a static method. So yeah, we can just do world. So that's the one for the grasslands. Now, as we do desert, we just have the same thing. We maybe abstract some of this stuff out later. We'll give it a different seed, so we get a different seed popping up. And so we have score is calc score. We're going to make that public. We'll have to make these public as well. Well, I love IDEs. They always tell you what you need to do to fix your mistakes. Okay, so let's give this a quick go. Okay, that's nice. I quite like that. It looks kind of similar to what we had last time with all the patches. It's quite interesting that there's some quite long regions of desert, so kind of long winding regions. And I wonder if that might be because we're actually now generating two different plasmas and comparing them rather than switching on the basis of a single plasma. So that might be something to look at a bit more. Okay, so let's just check that this is working, because if this is working, we should be able to have an arbitrary number of biomes in place now. So let's have vox. So the rocks is just going to be more sort of rocky sort of environment. So lib dot, what should we have? Let's have some granite. We'll give it a different seed number, so we get different spaces. We can probably have a different kind of variation here. World gen dot plasma, return the score. I mean that looks reasonably sensible. Yeah, we've customized that. Back to our world gen. Yeah. Rocks. This. So select biome. Should be able to now be choosing between three different alternatives. Let's just give this a go. Okay, I mean this is kind of interesting. Seems to have worked. We now get three different biomes mixed together. Obviously, they're all tightly compressed at the moment. They'll need to be made a little bit bigger. But I'm kind of liking the shapes that are coming up. We've got it kind of looks like almost like burnt land. This quite sort of brutal. I think it probably needs to be a bit more sort of spiky. But I can imagine some lava lakes and jagged rocks sticking out of these sort of stony plains. So it's got a bit of a sort of Mordor feel to it. Okay, so let's just try making these biomes a little bit larger. So we're going to need to make sure that the biomes sort of have a sensible sort of scale to them. So let's have some kind of overall scale for biomes. So public static double biome scale equals, let's make it 100 for the moment. So this is going to be the standard scale that we use for our biomes. Of course, the biomes could do something different. They could multiply the biome scale. They could divide the biome scales. They don't have to use this sort of standard, but by making it a global variable that scales everything, we can more easily control the overall world generation as we need to. So let's, for example, this on the desert, say we want the rocks to be slightly larger biomes, we can make it a sort of a 1.5 scale. So now we should be getting much larger biomes if we run this. We just landed in a large sea. But yeah, that's looking a little bit better. That's looking a bit more like what we want. We want the sort of biome areas to be a bit larger, so that they've got a sort of distinctive feel to each other. And I think in the end we're going to make them much larger than this. But for development purposes, I think it's good to make them fairly small and compact, so that you can sort of see what's going on more clearly. Okay, so now the one thing that is a little bit weird that I see is that, well, we've got these bushes generating in the desert. That doesn't make a huge amount of sense. We have grass is only actually, I think it's growing on only on top of the grass blocks, but that's a sort of a global thing. It's not really biome specific. It's just it grows on top of grass. So we definitely want to fix this a little bit, because it wouldn't really make sense to have a large area of rock with these sort of bushes growing inside. So I think what we want to do is change the way that the biomes get decorated a bit. So yeah, we don't really want a tree to generate in the rocky biomes either, or in the desert. That sort of doesn't really make very much sense. So let's have a quick look at the decoration code and see how we might be able to modify that. So what do we got? So we've got a bit of logic here to add something on top of the land if it's a grass. Now, this to me doesn't make too much sense because the biome could be generating anything as the top block. So I think we kind of want to move this this piece into the biome class itself, so it can decide whether it wants to add some kind of decoration on top. So what parameters have we got? We've got like X, Y, height. Now grassiness is obviously specific to the sort of grassland sort of biome, and the noise here is probably going to be grassland specific. So I think that probably this entire piece here is sort of going to be a new function, which is like a biome specific decoration. So let's do this. Let's do biome dot add tile decoration. And now in this case, we actually have a z coordinate because it's taking into account the height. So x, y, and the height, ht. So let's just create our abstract method. Now, in fact, probably this doesn't need to be abstract because the default behavior is probably to do nothing at all. So let's just have that in like that. We might as well make this public. I think it's kind of like a fairly public method for the class, and let's just customize this for the grasslands only. So if we are in the grasslands, we're going to override that method for add tile decoration, and let's cut out our decoration code, put it in grasslands, and what's happening here? Well, snoise is world-bound function, so we're just going to need to put in a thing for that. Now top, we know it's grass in this case, so we don't need this test. What I'm doing is I'm just literally looking at what the warnings are, and that's telling me what I still need to fix. So engine, I guess, is going to be needed quite often. This is actually the world. So let's just make this a function. Create method engine. And we're going to want to probably put this in the A biome class. So whenever we get an engine, where we need an engine, we're going to take the engine from our world gen. Dot. World gen dot get engine. Create a method get engine, and we're just going to return engine. So this engine instance is stored within the world gen, so we just need to do a little bit of plumbing to get that. World gen dot get engine. That looks sort of same. Grasslands. So I think the grassiness, we're going to want to be a bit more grassy in the grasslands. So let's drop this down a bit. yeah, so the higher that number is, the less grass we get. So this is sort of reducing it, is going to give us more grass. So we should now only see the grass generating in that land, and let's just do something to give the rocky terrain a bit of decoration as well. So rocks have exactly the same function. Let's call this rockiness. Um, and we want this to be fairly rocky, so let's make this sort of like 100. And instead of using grass, of course, we're going to want some kind of rock. So let's use granite. Let's give these slightly different seeds. Just going to help give a bit more variation. Let's give this a go. Okay, so the grassland, well, I still see some grass in the grassland. That's good. And wow, okay, so this is crazy. So yeah, that's definitely gone pretty rocky. We've got a lot of extra blocks of rocks scattered around some parts of the rocky area. I kind of like that. I kind of like that there's variation in the rockiness. Um, so in the same way we have variation in the grass, we've got variation in the sort of rocky areas. It looks pretty chaotic, a bit difficult to traverse. We maybe want to get some more variation of rock types in there, but that's looking pretty promising. And of course, then it completely stops when you hit the sand. The sand has not got the rocky feature. We get this nice sort of change in texture when we hit the sort of the edge of the biome. So that's kind of fairly believable, I think. Okay, and so what else? What else can we do with this? So we've got some rocks, we've got some desert, we've got some grassland. Um, I think one of the things we want to do, but it's probably going to take a little bit more time, is to make the rocky areas have more hills. So actually to modify the height generation for the different biomes. And this is going to be important anyway when we get to things like hilly biomes. We're going to want the hills to sort of ramp up in those areas. So we're going to want to do that. I'll probably have a look at doing that in a future session. But I think this is looking pretty good so far. Let's maybe add a different rock type. I think maybe possibly there's a bit too much of this rockiness, but maybe we want a bit of different types of rock in here. So let's just try doing that. So we said we was going a little bit too crazy with the rocks. So let's maybe put that up to like 300. But let's have a different case here so we can get a different rock type. So we have the granite. What other rocks do we have? We have the sort of regular stone. Yeah, stone is probably a good choice. Will probably mix in quite nicely. So what's actually happening here, just to explain briefly, is the rockiness is determining like how much rocks are getting generated in that area. We're then creating a random number up to that rockiness limit, which is using this sort of random int feature. And then if that random number is 0, we're going to get a granite. And if the random number is 1, we're going to get a stone. And for any other random number, we're going to get nothing, which is why the rockiness, the higher the number, the less rocks we're going to get. So let's just give this a quick try. So no rockiness in that area. And we do have rockiness in this area. And that looks, yeah, I quite like that. It's I think the standard stone blocks sort of stand out quite a lot, whereas the granite blocks obviously just sort of, you know, they're the same color, so they kind of blend in. I think that's kind of working. There's sort of kind of a scattered field of boulder kind of effect. We could actually use the boulder. There's sort of a sort of a square blocky boulder. Let's just give that a quick try, see what it looks like. Boulder. So the boulder is like the stone, but it's got a slightly different texture to it. Yeah, that's. I think that looks a little bit better. Square boulders feel a little bit odd. We might maybe think about getting like a circular boulder model in there, or sort of some octagonal model. Might make them look a bit more realistic. We don't have to go for the cuboid look for absolutely everything in the game. So that might be another future modification. The one thing is, I'm not seeing any of the sticky up granite blocks, and I think, yeah, I'm not seeing any of those at all. So what I think is happening is, as usual, I have made a coding slip up, and yes, what I've done is I didn't put in a break here, so we want to break after each of these cases. Because what was happening was it was setting it to granite. If it was 0, it was setting it to granite and then setting it to a boulder. But the boulder was obviously then just overwriting the granite. Go to Grasslands. Grasslands, I do have the break in there. It's a bit strange that I lost it when I copied it across, but that should be a bit more promising. Let's just have a go. Back to the world. Yeah, that's kind of more like what I was expecting. We've got kind of a mix of the sort of the granite outcrops, the spiky granite pieces, and the sort of the stone boulders that have mixed in. And I kind of like that. It sort of feels a bit natural. Yeah, you've got this sort of standard bedrock uh, kind of covering of the land, maybe some volcanic eruption covered it in some sort of some hardened rock, and the boulders are a different kind of rock, so they must have been carried in by some ancient glaciers or rivers or something like that. So yeah, I think that's looking quite that's looking quite good. We've just got a little bit of desert popping in here. That's kind of interesting. A little bit of grassland popping in here. And we're going to have to do something about the trees, but I think that's I think we can count that as a success for today. We've got the basic biomes working, and we're going to be able to hack on that a little bit more to make them get a bit more of a unique feel for each area. All right. Well, thanks for watching. Hope you've enjoyed the quick dev session, and take care and see you soon. Bye for now.